So now we have our equations for an ellipse. If you watched the previous video, I know I derived the equation of an ellipse there, and I know I got quite long. That particular calculation gets really messy before it finally cleans up. So just in case, you do a quick review here, this is the equation of an ellipse. It's x squared over a squared plus y squared over b squared, or the other way around. And the rule here is that A is always bigger than B. Okay, and what the difference is over here when the big number is under the x squared, you get an ellipse that looks like this, and over here when the big number is under the y squared, you get an ellipse that looks like this. Right, and we're making this assumption, the same assumption we made with the parabola, that the center is in the origin. The center is at the origin, and then we have these points, right? The focal points are in here, inside the ellipse, and this distance is c. The major axis, that's the long axis, has a length of a, so this is going to be a here. The minor axis, that's the shorter one, that one's going to be b. And we have this relationship here between a, b, and c. Okay, so really quick, that's the equation of the ellipse. We talked about it in more detail in the previous lecture. So let's see how we can use this. Right, so I want to find the equation of an ellipse whose center is at the origin and that has a focus at over 2 up 0, so that's a focal point, and has a vertex at negative 5, 0, so that's 1, 2, 3, 4, 5. There's a vertex. Well, remember, these focal points and the vertices, they're symmetric around the center. So if one vertex is at 2, 0, if one focus is at 2, 0, then the other one will be at negative 2, 0. And if one vertex is at negative 5, 0, then the other one will be at plus 5, 0. Okay, so that, more or less, is our ellipse. Okay, and I want the equation. Well, remember what the equation looks like. This is a left to right ellipse, if you will. So A, the bigger number, is going to go under the x squared. And B, that's the bigger number, is going to go under the y squared. And this whole thing equals 1. All right, well, A is I call it the major axis. The major axis is the line that runs through the ellipse. I mean, this part here is just on one side. Technically, that's the semi-major axis, and it has a length of 5, and that's going to be A. All right, so excellent. That's the first part here, x squared over 5 squared. And let's see, we got to work on B. So this distance here from the focal point to the center, that's going to be c. So c is 2. And remember, we have our equation there. B squared equals a squared minus c squared. And I know a and c, right? So a is 5 and c is 2. That's 25 minus 24. That's b squared is 21. And stop right there. You don't have to take the square root to actually solve for b. Because remember, our equation over here has b squared in it. So this is going to be y squared over 21. Right? And we can go a little further, right? Let's make this 5 squared. Let's make that 25. Right? And that's it. That's my equation of the ellipse. That's the equation of my ellipse. All right, so you can pause this if you like. Take a minute, see if you can't work this out on your own. Then start it up again and we'll go through it together. All right, so we're working the same situation here, right? We have an ellipse whose center is at the origin, so that's going to be here still. Has a vertex at 0, -3. So this is a vertex. And if it's got a vertex at 0, -3, then it's got a vertex at 0, +3. And a focus at 0, 2. So that's here. Focus at, whoops, excuse me, that's here. And if it's got a focus at 0, 2, then it must also have one at 0, -2. All right, excellent. So I can kind of see my ellipse now, right? It's going this way, so it's going to be kind of an up-down one. And C is going to be 2. And here the distance from the center to the vertex, that's A, and that's going to be 3. All right, so that means I can get B, right? B squared equals A squared minus C squared, which is 3 squared minus 2 squared, which, let's see, 9 minus 4, that's 5. Great, so now I have my equation. My equation is going to be x squared over b squared plus y squared over a squared. Remember, a is always the bigger number, and that has to go under the y here because this is an up and down ellipse. So let's see, b squared is 5. So I've got x squared over 5 plus y squared over a squared. A was 3, so 3 squared is 9. And that's it. There's my equation. Right, we're done. Okay, so suppose I don't want the center to be at the origin. I want it to be somewhere else. We're going to do the exact same thing that we did with the parabolas. You're going to start by leaving it at the center, and then when you're done, your very last step is going to be a translation. So if you want the center to be at h comma k, then the equation will be x minus h squared over a squared plus y minus k squared over b squared equals 1. And the a's and b's might be reversed, right? Depends on which direction the ellipse is oriented. All right, so let's see if we can find this equation. The center is not at the origin anymore. It's now at 3, -2. That's the center. It has a vertex at 3, 8. That's all the way up here. And this distance from the center out to the vertex, that's 10, and that's going to be A. And it has a focus at 3, 5. 1, 2, 3, 4, 5. So this distance, that's going to be C, and that is 7. Okay, so from that I can get B. B squared equals A squared minus C squared. That's 10 squared minus 7 squared. 100 minus 49. That's 51. Okay, so what's my equation look like? It's going to start where we're not going to worry about the center just yet. It's going to be x squared over b squared plus y squared over a squared equals 1. All right, so a squared, that's 10 squared, that's 100. And b squared is 51. So x squared over 51. All right, so far, the center is at the origin, right? To get it over to 3, -2, I'm just going to do a translation. I'm going to replace the x with x minus 3. That's still squared over 51. And I'm going to replace the y with y plus 2. oh, not over 51, excuse me. It's over 100. And that equals 1. And that's it. That's my equation, right? I would stop here. That's a perfectly good place to stop, right? Okay, so why don't you try this one, right? Pause the presentation, see if you can work this out, start it up again, and we'll do it together. All right, so we're starting with the same situation. The center is now at 2, -2. It's down here. There's a vertex at 7, -2, so that's A, right? A is the distance here. That's going to be 5. And it has a focus at 4, -2. So this distance here is C, and that's going to be 2. Okay, great. So now I can get B. B squared is other way around. Sorry. A squared minus C squared. That's 5 squared minus 2 squared. 25 minus 4. That's 21. All right, so let's go to the equation. Right? It's going to be x squared over a squared, because this is opening, or this is kind of a left or right orientation, plus y squared over b squared equals 1. A is 2, so 2 squared is 4, plus y squared over 21 equals 1. And now we got to fix the center, right? The center is at 2, -2. So the x gets translated 2 units to the right. This becomes x minus 2 squared over 4 plus y plus 2 squared over 21 equals 1. And that's it. Right, there's my equation. All right, so now once again, we're going the other way, right? Now I've given you an equation, and I want to know where all the interesting bits are, right? Where's the center, the focal points, and the vertices? Well, I need to make it look like x minus h squared over a squared plus y minus k squared over b squared equals 1. And the a's and b's, again, they might be the other way around, right? It depends on who ends up being bigger. All right, so let's see. I'm going to follow my usual approach. I'm going to first move the 4 over to the right-hand side. I'm going to make this equals minus 4. Then I'll do some completing the square. X squared plus 4x. Remember how we find the number to add? I'm going to take 4 divided by 2 and square it. That's 4. So if I add 4 here, this bit turns into a perfect square. But I can't do that, right? I got to balance it, so I'm going to put a 4 over here as well. Now I'm going to do it again with the y's. Plus 4y squared. Oh, wait a minute. Remember, we can't complete the square when there's a number in front of the y squared. But that's okay. I can fix this. Let's just factor out the 4. Make this 4 times y squared minus 2y. Now let's see what we're going to add. I'm going to do minus 2 divided by 2 squared. That's 1. And remember, I didn't add 1, right, because of this 4. I really added 4 times 1 to the right side. So I'll add another 4 over here. And now I'm going to get some factoring. This is x plus 2 squared plus 4 times y minus 1 squared equals 4. All right, and we're almost there, but remember, I need this to equal 1, right? That 1 is a really important number. It has to equal that for me to pull out the A and the B. So let's just divide both sides. Divide everything, if you will, by 4. And we end up with x plus 2 squared over 4 plus y minus 1 squared over 1. I'm going to go ahead and write it like that, right? Because I want you to see what the A and B are going to be. And this equals 1. Okay, so the 4 is bigger, right? So this is the A. A squared equals 1. Equals 4, which means A equals 2. B squared equals 1, which means B is equal to 1. And then I can go to my formula, right? A squared equals B squared plus C squared. I need C. I'm going to need C to know where the focal points are. So 2 squared equals 1 squared plus C squared. Let's see, this is 4 minus 1, so 3 is equal to C squared. C is the square root of 3. And this C, these A, B's, and C's, they're distances, right? So just go with the positive result. Okay, now I know what I'm looking at. This is a side right to left graph, and the center is at, I'm getting this from this part, the center is at -2, 1. So I'm going to go -2 and 1. There's my center. Okay, now where are the focal points? Well, to get to the focal points, I go C units in either direction. So I'm going to go square root of 3, that's about 1.7. So I'm going to end up here and here. And I'm just going to leave the square root in there. We're not really trying to graph them, so there's no reason not to keep those. It's going to be -2 plus or minus the square root of 3, 1. All right, where are the vertices? Well, to get to the vertices, I go 2 units. Right, so I'm just going to be here. Let me grab another color. I'm going to have a vertex here and a vertex here. So the vertices will be at -2 plus or minus 2, 1. And this I can clean up, right? This is -4, 1 and 0, 1. Right? There are my, now did I get everything? I got the center, I got the focal points, and I got the vertices. That's the whole story, right? That's the answer. All right, so why don't you give this one a try, right? Pause it and take a minute, see if you can work through this, then we'll do it together. All right, so I'm going to start by moving the 9 over, right? So this is going to equal -9. And look, this x, if this x squared, what does that tell me about the x coordinate of the vertex, of the center? Well, remember, this is going back to the original ones where we didn't do any translations. The x coordinate of the center is going to be 0. Now let's see, I'm going to factor a 3 out of the y's, and then I have to add something. So I'm going to do -4 divided by 2 squared. That's 4, so I'll add a 4 here. And remember, don't forget that 3. This is 3 times 4, so I'll add a 12 here. So now my equation is x squared plus 3 times y minus 2 squared equals 3. Divide everything by 3, and we get x squared over 3 plus y minus 2 squared over 1 is equal to 1. Okay, so the 3 is bigger. That means a squared equals 3. So a is the square root of 3. B squared equals 1. So b is 1. And now I can get c. A squared equals b squared plus c squared. Let's put numbers in. Square root of 3 squared equals 1 squared plus c squared. Square root of 3 squared is 3. 3 minus 1 is 2. So c squared equals 2. C is the square root of 2. All right. The bigger number was under the x. So this is a left-right ellipse. The center is at 0, 2, right? I got that 2 from here. So I'm going to go over 0, up 2. Then for the focal points, C is the square root of 2. So I'm going to go the square root of 2 to the side. So the focal points will be 0 plus or minus the square root of 2, comma 2, which is just plus or minus the square root of 2. And for the vertices, I go a units to either side. So the vertices will be 0 plus or minus the square root of 3, comma 2. And that is a little further, right? You can confirm that with your calculator. Square root of 2 is 1.4, square root of 3 is 1.7, give or take, right? Those are rounded. So this is plus or minus the square root of 3, comma 2. And that's what I was asked for, the center, the foci, the focal points, and the vertices. Okay, so what's next? We've got one more to go, right? In the next set of lectures, we're going to look at hyperbolas, and we're going to follow the same pattern. First the geometry, then the equation, then we'll do some examples with it, then we'll do some translations to get the center away from the origin. Excuse me, to get the center away from the origin.